Welcome to my chemistry channel Rapid Chemistry. I am Ranjan Das. Would like to discuss a very important unit of organic chemistry for ICSE and CBSE class 10 students. Okay, and that is hydrocarbons. Hydrocarbons. So today we'll discuss this unit taking reference of this book Concise Chemistry class 10 of ICSE. Okay, let's start and come to the page number 197 of your book in the latest version. So we'll start with hydrocarbons. Hydrocarbons can be alkanes, it can be alkenes, and it can be alkynes. And hopefully you know that hydrocarbons can be saturated and can be unsaturated. Saturated means single bond. Okay, there should not have any double bond, triple bond. And unsaturated means the compound should have at least one double or triple bond. So alkanes, these are the alkanes. And the simplest alkane is methane, and then ethane, and then propane, and then butane, and then pentane, and so on. And these are the homologous series of alkane. And the alkanes having general formula. Alkanes having general formula CnH2n plus 2. Can you see here? Okay, CnH2n plus 2. So if you put n equals to 1, you will get methane. If you put n equals to 2, and you will get ethane. And in this way, successive members you will get. Okay, so these are the alkanes. So alkanes are the hydrocarbons having only carbon and hydrogen, and they are attached with a single bond only. No double bond, no triple bond. Okay, so and here alkanes are also called paraffins. Okay, alkanes are also called paraffins. So few alkanes given here in the chart, and they are methane, ethane, propane, butane. Butane can be two, normal butane, so without any branch, and one isobutane is there with one branch. Okay, so and pentane can also be different, and we'll discuss on the very next page. Okay, so these are the molecular formula, these are the structural formula, and these are the abbreviated condensed formula. For the beginners, I will definitely suggest to write structural formula always, but it's not possible to write structural formula always, and then you better write condensed formula. Okay, condensed formula, not the molecular formula. You must write condensed formula. Okay, so that was the very page number 197 so of alkane. So one reaction is there here. Can you see one reaction? So that is the combustion of methane. So whether it is methane, ethane, propane, or butane, whatever it be, so in all the cases, so hydrocarbon will oxidize to produce CO2 and water vapor. CO2 and water vapor, and that is the complete combustion. In case of incomplete combustion, I will definitely say in this unit that there may be carbon monoxide and water, and even carbon particles or the carbon shoot can also be there. So let's move to the very next page, page number 198 here in your book. Okay, sources of alkenes. The principal sources of alkenes are natural gas and the petroleum. Natural gas contains mainly methane with smaller amount of ethane, propane, and butane. So now we'll study the isomerism in alkene. So isomerism in alkene up to propane, and there are no isomers. Okay, isomerism is not shown up to propane, but from butane we can have isomers. Okay, so here, so for C4H10, with C4H10 we can have different compound. We can have N-butane without any branch, and we can have 2-methyl propane, and better known as isobutane, as one branching is there. Whenever one branch is there, so generally prefix iso is written, and whenever two branches are there, so we will use neo. Okay, NEO. So that is the two isomers of butane. Okay, so now let's move to isomers of pentane. Pentanes and C5H12. C5H12. Okay, C5H12. C5H12 can have different formula. The first one here is pentane, common name N-pentane. N means normal. Okay, so the next one here is can you see one branch is there, and that is isopentane, and two branch are there, and that would be neopentane, and the neopentane IUPAC name is 2,2-dimethyl propane. Okay, so a few more information from this page. Methane is called Mars gas as it is found in marshy land. And one more important point, cavities in coal contain 90% methane. It is called fire damp. Okay, methane is a greenhouse gas, after carbon dioxide. Methane is the second contributor in greenhouse effect. Okay, so that was all about page number 197 198 of hydrocarbons alkenes in this book. Okay, so now we'll move to the very next page, structure of methane. So initially it was thought the methane having structure like this, simple structure, two-dimensional. But the scientist Van 't Hoff and Label predicted that the structure of methane and all the organic compounds, and having said that kind of structure, and it is the three-dimensional arrangement, and the specific name is there for this arrangement, and it is tetrahedral, or the structure is called tetrahedron, that geometry is called. So methane, you can have electron dot formula. It is the structural formula, and it is the actual three-dimensional arrangement of methane, where each bond angle is found to be 109 degrees 28 minutes exactly. Now let's move to the very next article, lab preparation of methane. Lab preparation of methane, one figure is there, can you see here? So preparation of methane, so sodium acetate is allowed to react with soda lime. And you know what is soda lime? Soda lime is a mixture of NaOH, sodium hydroxide, and CaO, okay, calcium oxide, or quick lime, calcium oxide. So sodium acetate, do you know the formula? Sodium acetate, CH3COONA, okay, CH3COONA, and it is heated with soda lime, and you will get the methane gas, and methane gas is lighter. Okay, methane, CH4. Okay, so it is molecular mass having only 12 plus 4, that is 16. So vapor density only 8, and whereas the vapor density of air is 14.4. So methane is lighter than air, and it will get collected by downward displacement of water, as it is not soluble in water, and we can collect methane like this. Okay, so actually the preparation process is not important here, but what you have to remember, and that is the reaction. Can you see here? Reaction, sodium acetate having formula CH3COONA, NaOH is there, or NaOH and CO, that mixture is called soda lime, and when it is heated at about 300 degrees centigrade, we are getting methane, and it is the side product sodium carbonate. Okay, so in the place of CH3COONA, if you take C2H5COONA, the same kind of reaction is there, one more, and in that case you will get ethane. Okay, CH3 is there, then CH4 will be there, and in the place of C2H5 it will be C2H6, and the reaction is here. Can you see? C2H5COONA. So these are the two preparation of methane and ethane in the lab process. Okay, at lab we can prepare methane and ethane like this. Okay, and the collection as I have just said, and the gas is evolved and collected by the downward displacement of water. Now two more important processes are there for the preparation of methane at the lab. So one is from iodomethane or bromoethane. So like this kind of compound, these are generally also called alkyl halides. Okay, one halogen is there, and that halogen can be substituted by nascent hydrogen, and the nascent hydrogen can be obtained by the reagent zinc powder and dilute HCl. Zinc powder and dilute HCl whenever react, and it will produce nascent hydrogen, and that will reduce the halides to alkane. Methyl iodide to get methane. Methyl iodide, another name iodomethane, and the ethyl bromide, another name bromoethane. So we are get ethane like this. So another important reaction here is Al4C3. Do you know the name of the compound? Aluminium carbide. Aluminium carbide reacting with water. So we are getting methane, and the side product aluminium, aluminium, the basic metal, and aluminium hydroxide will form. Okay, aluminium hydroxide. So one more reaction here for the preparation of ethane, mainly not methane. Methane can be prepared by this process, which is called Urge reaction. And what it is all about? 2 moles of methyl iodide is taken. 2 moles of methyl iodide is taken. Okay, 2 moles of methyl iodide is taken, and it is heated with sodium in dry ether. Water is avoided. In all the reactions of sodium, water should not be there. Okay, otherwise there may be explosion on, because hydrogen gas produced, and that may easily burn, and there may be a problem. So methyl iodide 2 moles reacting with sodium in dry ether, you are getting ethane. So that is all about the preparation of methane. So we did preparation of methane. The first one we did in the lab process, methane, ethane, similar process. And the second is the reduction of alkyl halide with a nascent hydrogen, and which is obtained at the cost of zinc powder and dilute HCl. One more with aluminium carbide whenever allowed to react with water. Okay, and that one is Wood's reaction, but in this reaction ethane is obtained but not methane. Okay, remember. So one important point here we'll discuss, and that is decarboxylation. As I have said, decarboxylation at the bottom. See, so the preparation, the lab preparation, whatever we have studied right now, in that reaction the CO2 or COO group is eliminated or removed, and that reaction, the lab preparation, is called decarboxylation. Okay, decarboxylation. Now let's move to the very next page here. So physical properties, we will not study physical properties. Okay, so we will study chemical properties. Okay, so physical properties are there. Physical properties of methane, not important, not needed at all. So chemical properties. So chemical properties, and one important point is written in italics. What is there? Let's see. Methane and ethane are saturated hydrocarbons. They do not react with bases such as sodium hydroxide, or with oxidizing agents such as potassium permanganate, or with reducing agents such as sodium metal. They undergo combustion reaction and as well as substitution reaction. So here the methane, ethane, these hydrocarbons, that is alkanes, will undergo complete combustion, incomplete combustion, that is combustion reaction, and they will also undergo substitution reaction. So in combustion reaction, so as I have said earlier, combustion reaction always products CO2 and water vapor, CO2 and water vapor, whatever the hydrocarbons, it doesn't matter. So you are always getting the same product. Okay, so if insufficient of air is there, then incomplete combustion may be there. So there you will get carbon monoxide. Okay, so even in very less amount of oxygen, methane can be oxidized to form carbon, that is soot and water. Okay, water vapor. So these are the combustion reaction for methane and ethane. Similar kind of reaction is there. Now we'll study substitution reaction. Substitution reaction of methane is very important, and the substitution reaction is the characteristics of saturated hydrocarbons, that is alkanes. Alkanes undergo substitution reaction because their valencies are already filled up with single bond. So if any group is to be introduced, one hydrogen needs to be removed. Okay, and that is really occurred here. So methane, whenever allowed to react with chlorine in diffused sunlight, okay, direct sunlight is avoided because that may lead to the explosion. So methane reacting with chlorine, so you are getting methyl chloride and HCl. That means one H is substituted by one Cl, and so on. From methyl chloride we are getting in dichloromethane, and again if we carry out the step, so trichloromethane, another name is chloroform, and at last we are getting carbon tetrachloride. And I can show that reaction in the summarized form like this. Okay, look at there. So methane initially is taken with diffuse sunlight, CH3Cl, and that is methyl chloride. Again diffuse sunlight, chlorine, CH2Cl to methylene chloride, then again chloroform, and then carbon tetrachloride. So just having a pause, you can write down that reaction, and you have to memorize with their name. So these are the substituted products of methane. Okay, so when methane is allowed to react with chlorine in diffuse sunlight. So next type of reaction here we have. So in the very next page, come to the very next page, and here the ethane is there. So ethane substituted products with chlorine are written, but not needed right now. You just have the logic here. So ethane 6 hydrogens are there, and in 6 steps, so 1H gets substituted with different products are there. Okay, different products. Now we'll study the decomposition of alkane. So at high temperature, so alkanes or alkanes can be decomposed to get the alkane can produce alkene or alkyne. Okay, at high temperature. So at high temperature, as I have just said, decomposition of alkane may be there, and that is said to be pyrolysis or cracking. Okay, at high temperature. And another reaction for or alkane, and that is catalytic oxidation. As its name says, catalytic, that is catalyst must be there, catalytic oxidation. And the catalytic oxidation, mainly two kinds of reactions we will study here. One taking an example of, so copper tube and at 120 atm pressure and 475 Kelvin. If you take methane, it oxidizes to form methanol. The same reaction if you take with ethane, that reaction, and observe, you will get ethanol. Okay, and here methane you take, then you will have methanol, and if you take ethane, then it will have ethanol. So another catalyst is molybdenum oxide, MO. Can you see molybdenum oxide here? So molybdenum oxide, MO. So it will be, if you take methane, then it will form methanal, that is aldehyde. And if ethane is taken, then you will ethanal. Okay, so these two pairs of reactions from the catalytic oxidation from alkane. Okay, so alkane, and the last reaction and what you have to remember from alkane part, and that would be, so that line or here as it is written, from slow combustion, alkane changes to alcohol, alcohol changes to aldehyde, aldehyde changes to carboxylic acid, and finally everything changes to here are carbon dioxide and water vapor. Okay, that means the terminal two position alkane, and another is carbon dioxide water vapor, and in between alcohol aldehyde acid, alcohol aldehyde acid. So for methane the line is written here, and methane, methyl alcohol, formaldehyde or methanal, methanoic acid or formic acid, and finally CO2 and water. And if we take ethane, can you predict the products? It will be ethyl alcohol or ethanol, and then acetaldehyde or ethanal, CH3CHO, then CH3COOH, and it will go on. So that was all about from alkane part. Okay, so now we'll start alkene. So alkene, let's come to alkene in page number 203, alkene. So it has also been started with similarly, okay, as it was for alkane. It is alkene. Okay, alkene, alkenes are also called olefins. Alkenes are also called olefins because they are oil forming compound, olefins. So the characteristics of alkene, alkene having general formula CnH2n, that means the number of hydrogen would be just double than the carbon atom. And it will start, the first member of the alkene series is ethene or ethylene. Okay, the trivial name or the common name initially it was ethylene, but IUPAC name is ethene. Okay, and then we have propene, butene, and so on, like this, pentene. Okay, so these are the alkenes. Alkenes are unsaturated, they are not saturated, they are unsaturated hydrocarbon because they having at least one double bond, at least one double bond is there, so they are called all unsaturated hydrocarbon. Okay, so now, so they can form isomers, and what different kind of isomers they will form. Okay, let's see. The first one here is chain isomers. Chain isomers, so one butene with C4H8, with C4H8 you can have these compounds. C4H, you can get 1 butene or but1ene along with 2 methyl propene. So they having different kind of chaining, but total number of carbon and hydrogen remain same. So they are isomers. And what kind of isomers they are? They are chain isomers. Okay, and the property of having chain isomers and is called chain isomerism. And here, so 1 butene or but1ene or 2 butene or but2ene, so they having difference in their position of double bond, so they are said to be position isomerism. Position isomerism. Okay, got it. So now we'll study the structure of ethane. Structure of ethane, and here structure of ethene or ethylene. So carbon carbon double bond is there and the bond angle 120, and it is a planar structure. Okay, now we'll study the preparation of ethene at the lab. Okay, so the lab preparation, and here so the reactants we must study, but the procedure we will not study. We just try to understand what is there actually. In a round bottom flask, ethyl alcohol is taken, and it is allowed to mix with conc H2SO4. You know, ethyl alcohol having formula CH3CH2OH. Better you just see that reaction. So that reaction is the summarized of these two. So better to study this one only. So ethanol, whenever allowed to react with conc H2SO4 at about 170 degrees centigrade, do you know what occurs? So ethanol, conc H2SO4 is a very good dehydrating agent, and it will dehydrate the water part. Water part means one OH and one H. One OH and one H is removed. So you are getting C2H4. The same reactions can be carried out using another dehydrating agent as written here, and that is alumina or Al2O3. Okay. So in this box, just observe. So ethanol or alumina, that is the solid dehydrating agent. So there may be question, name one solid dehydrating agent. So it is Al2O3, and the liquid dehydrating agent we have just seen there, and that is conc H2SO4, concentrated H2SO4. So that was the lab preparation of ethane, and that means using dehydrating agent. Better conc H2SO4, and another can be used, and that is Al2O3. So one more preparation is there for the preparation of alkene or ethane, and that is from their halides compound. So halide compounds, so ethyl chloride, ethyl bromide, ethyl iodide, that is ethyl halide. These three can be called as ethyl halide. So whenever they are allowed to treat it with KOH, that is potassium hydroxide in alcoholic solution, and there will be dehydrohalogenation. What is dehydrohalogenation? D means actually removal of hydrogen and halogen simultaneously. One hydrogen atom and one halogen atom will remove from here in presence of alcoholic KOH, not aqueous KOH. It is alcoholic. Okay, ALC for alcohol. Alcohol medium the reaction will be, and you are getting 1H and 1 Cl is removed. You are getting C2H4, you are getting C2H4, you are getting C2H4. Similar kind of reactions. Okay, these are the side products. Okay, so the main product you must have to write. Okay, so from alkyl halide, by the process of dehydrohalogenation, the halogen is removed along with one hydrogen, and we are getting alkene. Now let's move to properties of alkenes. So physical property will not study. Okay, so but one point is important here. It produces an anesthetic effect upon inhalation. You know anesthetic effect? Okay. Now, so chemical properties, you know, the alkene, and that is unsaturated hydrocarbon, and the characteristic reaction for unsaturated hydrocarbon is addition reaction. Addition reaction is the characteristics reaction for the unsaturated hydrocarbon. And addition means something is getting added, and what is getting added here? So ethene, hydrogen can get added here in presence of nickel catalyst at about 200 degrees centigrade, and you are getting ethane, and the reaction temperature is 200. So in the place of nickel there can be some other catalyst like platinum, palladium. Okay, and another reaction is there, say addition reaction with halogen. So okay, let's move to the next page here. So halogen and ethene can react with Cl Cl2, if it is allowed to react with Cl2, both the carbon will take one Cl, one Cl, one Cl, one Cl. So the product will be 1,2-dichloroethane. And if it is allowed to react with ethane plus bromine, so the double bond will no more be there, it will become single bond, and it will get added, because as we are studying the addition reaction, and each carbon will take one bromine. So that reaction is very important. That's why I have marked star sign here. So and it is important, that's why it is written and here. So it is the identification test of alkene, okay, because in that reaction the bromine color changes occur for bromine, and on saturation, that means presence of double or triple bond, can be understood. Okay, so what is written, let's see. Bromine solution in CCl4, that is carbon tetrachloride, has an orange color. Okay, when added dropwise to ethene, the orange color of the bromine disappears due to the formation of the colorless ethylene bromide or 1,2-dibromoethane. So that is the identification test. You must have to remember, very important here. Okay, and for the addition reaction, no need to study anymore here. And let's come to the right column at the top, and that is the polymerization reaction. And polyethene, everyone know, so polyethene, polyethene, that means large number of ethene can be combined at very high temperature and high pressure to form polyethene. And one last reaction from the alkene part, and that is with KMnO4, alkaline KMnO4. It can also be used as a identification test for ethene, and there will be color change of KMnO4, okay, and the product will be, both the carbon will have one OH. So that is ethylene glycol, common name ethylene glycol, and the IUPAC naming is also given there. The purple color of KMnO4 decolorizes. And the combustion reaction, no, nothing to say, because as we have already said, whatever the hydrocarbons, for complete combustion, product will always be same. Okay, and uses the preparation of polythene for the ripening of fruits. Okay, so these are the common uses, or oxyethylene flame can be there. So these are the reactions and the alkene part. Okay, so one more part we will discuss here, and that will be alkyne. But one thing I must have to say, so there is exercise in your book. You must go through the exercise very seriously, and if you have any difficulty, you can write in the comment box, and I will definitely respond. Okay, so next is alkyne. So we'll complete alkyne in very short, because very selective questions are coming in ICSE or CBSE class 10 exam from alkyne. So alkyne, at first you have to identify alkynes. Alkyne means there should have at least one triple bond, carbon-carbon triple bond should be there, and their general formula is CnH2n-2. Do not forget, their general formula is CnH2n-2, and the first member of the alkyne series is ethyne, CH triple bond CH. Okay, ethyne. And then we'll have propyne and butane, and like this. Okay, similarly. And the difference with alkene, only in the presence of a bond, double bond on triple bond, and the number of hydrogen atom attached with carbon will differ definitely, keeping in mind the valency of carbon will always be 4. So alkyne can also form isomers, and you know, position isomers can be there, but-1-ine, but-2-ine. Okay, but-1-ine and but-2-ine. So molecular formula of acetylene is C2H2 here. And now we'll study the structure of ethyne. Structure of ethyne or acetylene here. Structure, that is the electron dot formula, the structural formula. Okay, structural formula, and the bond angle here is 180 degree. Okay, now we'll study the lab preparation of ethyne. Lab preparation of ethyne, what is there? Okay, so just look at the figure number 12.5 here. So the lab preparation, the reaction is exothermic, and the acetylene or ethyne is produced by this reaction, CaC2. And do you know the name of the compound? And it is calcium carbide. Okay, calcium carbide reacting with water, and it is allowed to fall dropwise, and we are getting acetylene or ethyne, okay, having sweet smell. The collection, and the gas can be collected like this by the downward displacement of water here also. And the purification we must have to study here, as it is marked there, because it has some impurities. On passing through water, all impurities except phosphine are absorbed. Okay, phosphine, that is pH3, is absorbed by passing through acidified copper sulfate. That's how we can remove. So at first we have to pass through water, and second we have to pass through copper sulfate, CuSO4. Then you will get the pure acetylene or ethine. Now we'll study the preparation, one more reaction for the preparation of ethine, and that is this one. We have already studied in the alkene part that alcoholic KOH is used for the dehydrohalogenation reaction. That means it will carry the halogen and hydrogen removed from that structure. Okay, and one Br taking one H, and this Br will another H. So what left? CH, and that's why the compound is ethine. Okay, so ethine. Now physical properties of ethine not needed at all actually, and we'll move to the addition reaction. And addition reaction, like similar to that of alkene. So if ethine is taken at the first step, we get ethene, and the second step, and here observe carefully, ethene. So at the second step we are here. So ethene changes to ethane at last. So these are the two steps can be summarized like this. So ethine to ethene, and then ethene to ethane. Okay, so there are many similarity in between the ethene and ethine. Okay, because both are unsaturated hydrocarbon, and the difference is just the having the presence of bond. In ethene or alkene compound, double bond, and here triple bond. So one more reaction here. So if you carry the reaction with Cl2, so in the first step triple bond will become double bond, and both the carbon will carry one Cl, and again if you add chlorine, so one chlorine more. So that is the final product. Okay, so similarly reaction with bromine we can do. So reaction with bromine, and that is also the identification test. So at first 1 mole of bromine is added, and the second again another mole can be added. So the rest of the reactions are not needed, I think, for your syllabus. Okay, so that is all about alkyne. Okay, so alkyne having some important uses for welding purposes, oxyacetylene lamp, okay, and the preparation of polymers, artificial rubber, oxalic acid. Okay, so in this unit today we have studied alkane, alkene, and alkyne. Now it's your turn. You have to go through the exercise part very carefully, and if you have anything to say, you may comment on the comment box, and I will definitely respond. So, okay, and the next day with next unit. Bye.